LABTECH innovations.
Hello friends, we have discussed a lot about probability. In probability, there is something called conditional probability. Conditional probability always depends on two events. We say that event A has already occurred, then what is the probability of B occurring, right? Or inversely, that means B has already occurred and what is the probability of A occurring, right? And we also know the notation for that. That is probability of A by B means B has already occurred. Now what is the probability of A occurring, right? So there are two events basically here, A and B. Now any event that happens in real time, two events happen in real time, then one event happens earlier and the second event appears later on. So the earlier happens means what? It is before, and later on means it is afterwards. Okay. So in mathematics, or I think in some kind of a Latin pronunciation, Latin notation is there, before is called a priori and after is called posteriori. I mean, I don't want you to understand or use this nomenclature, but then you should understand when I say a priori, I am talking about the event which has happened before, and when I say posteriori, that means I am talking about the event which has happened afterwards. Let us take an example so that my statement will be clear to you. So let us imagine there are two jars, two bowls. There is one bowl and there is another bowl. Okay, simple. Now this bowl contains, let us say, 5 black balls and 4 blue, say red balls. Okay, and here let us say 6 black balls and 7 red balls. Okay, this bowl let us call it A and this bowl let us call it B. Now I am talking about two events. Two event means what? This is the first bowl, this is the second bowl. What I am going to do is I will pick up one ball from this bowl and put it into the second bowl. Okay, so this event has happened first, right? So it is before. Okay, and then I pick up one ball from this bowl. Okay, so this is before and this is after. So it is very clear which event happens first. One ball which is transferred from A to B, that is the first event, and second event is the ball which is transferred from B, that happens afterwards. Okay, now there are two types of questions asked in probability problems. One is they will give you what happened in the first event, what happened before, and they will ask what will happen in after. That means they will ask you probability of B by A kind of a thing. That means they will ask you what is the probability of this event occurred afterwards before, provided the event which has occurred earlier is given to you, is known to you. So that means A has already occurred. Now what is the probability of B? So here B happens afterwards and A happens earlier. Okay, but if I ask you this probability of A by B, that means I know what happens in B and I want to find out what would have happened in A. So I know what has happened afterwards and I want to find out probability of what might have happened before, right? So here we are reversing the order, and here this is called chronological order. Chronological order means some event happens, that is before, and some event happens afterwards, that is called second. So that is a chronological order. So this event, you can ask the question like this. And now for example, I'll give you an example so that it will be clear. Okay, so now let us remove this and now let me define certain events. So the first ball is transferred from the bowl number A to bowl number B. Okay, that happens. Okay, now that event can be divided into two parts because we do not know which ball goes here. Maybe black ball goes or red ball goes, but both balls cannot go. Therefore, these two events are mutually independent. That means A union B, probability of A union B is just probability of A plus probability of B, right? That means first ball transferred may be black or may be red. So there are two events. When I say But we are interested not in this event, we are interested in what happens afterwards. So I am interested in finding out whether the second ball picked up from the bowl is red or not. Okay, so I am going to call that event R2. 2 because it is a second bowl. Okay, what is the meaning of R2? R2 means we are talking about the second ball chosen from the bowl B. The bowl B is red. Very clear, right? So the R2 is this event, second ball transferred from the bowl B is red. Now there are two events, as I said, occurring first. I will call first is R1 now. First ball transferred from A to B. Okay, that is R1. And R1 bar means what? The first ball is not red. That means first ball is black. Okay, so first ball is not red, which means it is black. Okay, now if I ask you question like this, what is the probability that second ball is red provided the first ball transferred was red? What is the probability? I'll write the question here. What is the probability of second ball being red if the first one transferred is red? Okay, is red. That is very clear. If I want to write it in a proper manner, it means I am interested in probability of R2 by R1. So R1 has occurred. That means it has already happened that the first ball transferred was red, right? I am interested in this, okay? Probability of R2 by R1, okay? So now there will be another event, probability of R2 by R1 bar, So the first ball transferred was not red. It is given to us that first ball transferred is not red. What is the probability that second ball will be red? Okay. So these are the events. Okay. Now these two events are mutually exclusive because either the first ball transferred is R2 or R1 or it is R1 bar, right? So therefore, I want to find out probability of second ball being R2. So I will define the entire problem like this. Going back to the same problem again, what is the probability that second ball is red provided the first ball transferred is red? Okay, so first ball transfer is red, that is the probability, and we want to find out probability of second ball to be red. Now, probability of R2. So what is R2? Let me make you understand what is R2. R2 means second ball is red. R2 defines second ball is red. But second ball is red, before that something has happened. The first ball was transferred, right? Now it may be R1, that means it may be red or it may be black, right? So black means not red, right? Therefore, the event can be written like this. First ball transferred was R1, that means first ball transferred was red. Then what is the probability and probability of R2 by R1? Then probability of R1 bar multiplied by probability of R2 by R1 bar. First ball transfer was red, and then what is the probability of second ball being red? First ball transferred was not red, then what is the probability of second ball being red, right? This is what we want to calculate. But this is very easy to calculate. You can clearly see what is the probability that the first ball transferred is red. How many red balls are there? 4. Out of how many? 9. So therefore, there are 4 favorable outcomes and 9 total outcomes, correct? So the probability of first ball being R1 red is nothing but 4 by 9. Okay. Now, we know that the first ball transferred is red. So number of red balls in this second bowl will increase by 1. Okay. So number of red balls are how many now? There are 8 red balls because we have added 1 to it. Okay. Now in that case, the total number of balls become how many? Total number of balls becomes 6 plus 8. That is 6 plus 8 means there are 14 balls altogether. Out of which how many are red? 8 are red. So therefore 8 divided by 14 is the probability of the second event. Because one red ball is added here and number of red balls have increased by 1 and total number of balls have also increased by 1. Therefore it is 8 by 14. So very easy to calculate and very common sense also. So common sense, what is the probability that it is not red? Not red means there is only one probability that the ball is black, right? So how many balls are black here? 5 balls are black. How many total balls are there? 9. So what is the probability that the second ball being black or not red? It is 5 by 9. Now that black ball has been transferred here, right? Black ball. So this is plus 1 and this is not, right? So this is not, okay? So this is plus 1. That means now look at the total. Total is still 6 plus 1, 7, 7 plus 7, 14. So out of 14 balls, how many red balls are there? That has not changed at all. So it is 7, okay? So this is the kind of question which may be asked. Now this kind of question bothers about what happens afterwards, provided we know what has happened earlier, right? So what happens afterwards, provided I know what has happened earlier, that kind of probability is called posteriori. I already told you. Posteriori, right? Now that is called posteriori. That means we are talking about the probability of second event provided I know what has happened in the first event. So it is chronologically correct. First and later on. So this total will be how much? Very simple to calculate because both the denominators are same. So 9 multiplied by 14, then it is 32 plus 35. Okay. Now I'm not interested in getting this, you get the answer. Okay. So this is how you can calculate the probability of this event. Now this is an event. This kind of probability calculation is called posteriori, right? Again, I'm telling you, I'm talking about the probability of second event provided I know what has happened in the first event. Okay. Now, we'll reverse the whole thing and we'll talk about a priori. A priori means we know what happens afterwards and we want to find out what might have happened earlier, before. Okay. That is called a priori. Now, the same question now can be changed. What is the probability that the first ball is red? What is the probability that first ball is red provided second ball transferred is red? So I know what has happened afterwards and I want to find out what happens earlier. Correct? That is called a priori. Now that is a slightly difficult question, it appears, because we can easily find out the probability of R2 provided I know the first event. But now I'm asked a difficult question in the sense that I'm asked a question about what might have happened earlier provided I know what has happened later on. Okay, fine. So let us try to do that questions. Okay, I'll repeat the question again. What is the probability that the first ball transfer is red provided second ball transferred is known to be red? Is known to be red. In other words, we are interested in finding the probability of R1 by R2. We are interested in finding the probability of R1, right? Provided the first ball transferred is red. Second ball taken out is red. We want to find out probability of R1 by R2. Okay. Now this is a reverse order. Now this reverse order problem can be converted into proper chronological order by using the definition of conditional probability. What is the definition of conditional probability? Probability of R1 by R2 is nothing but probability of R1 intersection R2 divided by probability of R2. Correct? So R1 intersection R2, probability of R2. I will be very happy if I can change the order. Instead of R1 by R2, if I want to find out R2 by R1, it is easier, as we have seen in the last problem, right? So I am interested in reversing the order. And this definition helps me here, because R1 intersection R2 can be written as R1 by R2 or R2 by R1, any way I feel like, right? So I am going to reverse the order and I will write it like this. So probability of R1, so I want to reverse the order, so it is probability of R2 by R1 multiplied by probability of R1. Even this is the definition of R1 intersection R2, right? This formula also well known to us. Now divided by probability of R2, correct? So now I have reversed the order. That means from a priori I am going to posteriori, because I am talking about the second event provided I know the first event, right? That is the triumph. Now I will further divide this problem into these parts. R2 by R1 multiplied by probability of R1. Okay. But remember, probability of second ball being red is a compound event, because first event has occurred, it is either R or black. So first event is either red or it is not red. So this event is actually divided into two mutually exclusive events, provided that R2 intersection R1, means first ball was red and second ball is also red, or first ball is not red, right? But second ball is red, R1 bar, okay? So this event is divided, partitioned into two parts, right? See, R2 intersection R1 and R2 intersection R1 bar. R1 bar. R1 bar means black ball, okay, not red, because there are only two alternatives here, okay? Is this clear? Now here I can have this representation or this representation, but I am interested in posteriori event, so therefore I'll do it like the same thing here. So probability of R2 by R1, okay, multiplied by probability of R1. Since I am interested in making it posteriori, I will talk about the second event first. Probability of R2 by R1 multiplied by probability of R1. Here also I will say probability of R2 by R1 bar multiplied by probability of R1 bar. So this convenient mechanism has reversed the order of all the events to be calculated. Look at it, R2 by R1, R2 by R1, R2 by R1 bar, which I know is very easy to calculate. So this kind of mechanism allows me to alter the order from a priori to posteriori, because that is easier to calculate. Now why it is easy to calculate? Just see. What is the probability of first ball is R, red? Simple, 4 by 9. There are 4 red and total number of balls 9, right? Now red ball is transferred here. That means the number of red ball here has become 7 plus 1. That means there are 8 red balls now, right? And 14 total balls. So 8 red balls out of 14. Okay, very simple. Divided by. Now you can clearly see this and this expression is absolutely same. So I don't have to change that. So 4 upon 9 multiplied by 8 upon 14 plus. Now first ball is not red, means first ball is black. The first ball is black. How many black balls are there? 5. Out of how many? 9. Okay. Now first ball transferred is black. So now the situation is this, that this has increased. This has increased. This has increased and this remains the same, right? The first ball transferred is black, right? So black ball has increased. So only total number of balls have increased, but red ball remains same. So it is 7 upon now 14. Can you clearly see that? Again I'll repeat. First numerator is first ball transferred is red. How many red balls are there? 4 out of 9. Then how many red balls are here? Because first ball was red, it is 8 and 6. So therefore this is the calculation. Now if it is not red, then this is the calculation. Now is 9, 14, 9, 14, 9, 14, all these factors get cancelled. So therefore the total turns out to be 32 divided by 32 plus 35, which means 32 upon 7 and 6. So the probability is 32 by 67. So a priori probability also can be found out by converting the events into posteriori. Okay, that means if I want to find out the probability of the event which has happened earlier, provided I know what has happened later, I'm free to use this kind of mechanism. Now this kind of mechanism is called the famous Bayes theorem. Now in order to generalize this theorem, let us have a look at what has happened here. Let us understand this entire situation by using Venn diagrams. Okay, so this was the original sample space. This was the sample space. Okay, this was the sample space. Okay, this sample space is divided into two mutually exclusive parts. So mutually exclusive parts. The first ball transferred was red and first ball transferred was not red. Okay, so R1 and R1 bar. These two events are mutually exclusive. That is why this happens to be partition of this sample space. Partition means what? Converting the space into different subsets such that no two of them have common intersection, but their total is the whole of sample space. So first event is divided into two mutually exclusive and exhaustive sets R1 and R1 bar. Now there is another event called second ball is what? R red. So that is called R2. Okay. Now you can clearly see that second event is this event, but this event is divided into two parts. One is this part and the other is this part. This is also partition of R2, right? So here this part will be called R2 by R1 and this part will be called R2 by R1 bar. You understand? So this part is the R1 has happened and within that the ball is red, second ball is red. R1 bar has happened, that means the first ball is not red. Within that R2 has happened, right? So these are two mutually exclusive. In other words, if I take original sample space and I divide it into several mutually exclusive but exhaustive parts, like that. There may be many. In my case it was only two, but here you can write it as E1, one event. This event is E2, this event is E3, this event is E4 and so on. Last is En, right? So what I have done is the entire sample space is actually E1 union E2 etc. union En, right? And this is mutually exclusive. Therefore, probability of S, is actually equal to probability of E1 plus probability of E2 plus probability etc. probability of En. Because these events are mutually exclusive and exhaustive, therefore entire probability will be reflected here, right? So it is divided into so many events, okay? Now, if I have another event A inside this, okay? Now the moment I have another event A here, now because of the original sample space is being partitioned, it naturally A is also partitioned. So A is partitioned into what? A is partitioned into A. This part is A by E1. This part is A by E2. This part is A by E3 and this will go on. The last part is A by En. Correct? So this problem gets divided into automatically. This original partition is inherited by this subset A. Okay. Now, therefore, I am interested in probability of this event, any one of them. Suppose I want to find out probability of, let us say, E I don't know number, so EI, correct? Probability of EI by A. I am interested in this probability, correct? So I am interested in probability of EI by A. So according to the definition of conditional probability, probability of EI intersection A plus, multiplied by probability of EI intersection A divided by probability of A. Correct? Fine. Okay. So now I have just picked up one of these events, one of these several events. I have just taken an EI. EI may be E1, E2, A3, and E4, right? The mechanism will be same for all of them, right? So probability of EI by A, I am interested in reversing it. So what I did in that problem, I am going to do here also. So that means I am going to write in the reverse order, probability of A by EI multiplied by probability of EI. Correct? Now I know that P of A is divided into so many parts, right? So what has happened in P of A by P of A? P of A is partitioned. A is already partitioned into so many n events, right? So that means I will have to write it like this. Probability of A intersection E1 plus probability of A intersection E2 and so on. Probability of A intersection En. Correct? That is what this is. This is intersection. Okay. Now this can be written as probability of A by EI multiplied by probability of EI divided by probability of now I am going to change the order. So it is probability of A by E1 multiplied by probability of E1. Then I'll write probability of A by E2 multiplied by probability of E2. And this will go on like this. The last will be probability of A by En multiplied by probability of En. Correct? So that means it is probability of EI multiplied by probability of A by EI. Okay? And this is a total summation. So I am going to write it as sigma. This is sigma. What is sigma? Probability of A by ER. Probability of A by ER, where R varies from 1 to n. Summation of all this, right? So this statement which I have written here is called the most famous Bayes theorem. Okay? This statement which I have written here is called Bayes theorem. But instead of remembering this, if you remember the procedure with which we have calculated Bayes theorem, the same procedure applies to many problems. For example, I'll give you one more problem of this type. Okay? So please note that probability of EI by A is equal to probability of EI multiplied by probability of A by EI divided by summation of probability of A by ER, where R varies from 1 to n. That is the Bayes theorem. Is that clear? I hope you have understood this theorem very clearly. Okay.